Good evening, everyone. Welcome to week 6 assignment solving session. Today I'll be discussing some questions related to week 6 lecture material and week 6 assignment solution. So let's start. So the first question is the lesser Lewis acidity of BF3 compared to BCl3 is due to option A is the more electronegativity of fluorine. B is the mixing of 2s and 2p orbitals of boron. C is the stronger 2p b pi and 2p f pi bonding. And D is the stronger 2p b pi and 2p f sigma bonding. So in BF3 we have already discussed the molecular orbital diagram. So this is how it looks like. Here is the energy. So there are 12 ligand group orbitals in fluorine because there are 3 fluorine and in 1 fluorine there are 2s1 and 2p 2s2 and 2p5. So S is only 1s and 3 p orbitals are there. So from 1 fluorine there are total of 4 orbitals, and from 3 fluorine there will be 12 ligand group orbitals will be there. So when molecular orbitals are formed, uh, the first 3 orbitals, molecular orbitals, are filled with electrons from boron. So in boron it is 2s2 and 2p1. So this first 3 orbitals will be filled from uh, 6 electrons from boron and uh, fluorine, and the A2 double prime, that orbital will be filled from uh, one lone pair of one of the fluorine. So in BF3, BF3 is how the bonding is formed. So one of the fluorine will be giving one of the lone pair to the A2 double prime orbital, so that a back donation is formed, and there will be remaining 1, 2, 3, 4, 5, 6, 7, and 8. 8 lone pairs will be filled in 8 non-bonding molecular orbitals. And here, because of the similar energies of fluorine boron atomic orbitals, the back donation happens, and a 2p pi 2p pi bonding is formed. So the answer will be option C, the stronger 2p b pi 2p f pi bonding. In BCl3, that back donation is not possible. So Lewis acidity of BCl3 is higher compared to BF3. The second question is Al2O3 on treatment with HF gives. Option A is ALH3, B is ALF3, C is Al2F6, and D is Al2H6. So this one is one of the method to produce aluminum fluoride AlF3. So Al2O3 reacts with HF and produces AlF3 and water. So answer is option B. Next question is for B5H9. The skeletal electron pairs SCP and the structure type respectively are option A is 8 and closo, B is 13 and closo, C is 7 and arachno, and D is 7 and nido. So for predicting boron hydride structures, we use Wade's rule. First, we have to determine total number of valence electrons, 3 per boron and 1 per hydrogen. Then subtract 2 electron for each BH unit, and remaining number has to be divided by 2, which will give the SCP, which determines the type of cluster. So here we are asked to find SCP and structure for B5H9. In B5H9, there are 5 boron. So 5B will give 3 per 1 boron. So 5 into 3 for boron. Then there are 9 hydrogen. So 1 hydrogen has only 1 valence electron. So 9 into 1. And there are no negative or positive charges. There are 5 BH units. That will be 5 into 2. And SCP is 15, 9 and 10. SCP is 15 plus 9 minus 10 divided by 2. That is 14 by 2, 7. So there are 7 skeletal electron pairs, and we have B5H9. So in B5H9, N is 5 and SCP equal to N plus 2. So 5 plus 2 is 7. So in this table we can see that if SCP is N plus 1, it's closo. If it's N plus 2, it's nido. N plus 3 is arachno. N plus 4 is hypho, and N plus 5 is clado. So we have SCP N plus 2. So N plus 2 is nido. So option D is the answer, SCP-7 and nido structure. Next question is A and B in the following reaction are gallium trichloride reacting with Me3SiH giving compound A, and it reacts with LiGH4 at 240 degrees Celsius giving compound B. So option A is A equal to gallium trimethane, B is gallium hydride, B is A equal to GaCl2H, and B is GaH3, and C A equal to Ga2Cl4 mu H2, and B equal to Ga2H4 mu Cl2, and option D is A equal to Ga2H4 mu Cl twice, and B equal to Ga2H4 mu H twice. So this one is synthesis method for digalene, and when we treat GaCl3 with Me3SiH, first it will form hydrogenated and galene with chlorine on bridging. So GaCl3 plus Me3SiH first forms. So this one will be the A compound, and this one on treating with LiGa 4 times, H 4 times at 240 degrees Celsius, it will form digalene. This Cl will be replaced with hydrogen. So whenever there is a bridge chlorine or hydrogen, that will be mu denoted as mu. So there is mu here, it denotes the bridging. So option D is the answer, uh, where A is uh, so option D is the answer, where A equal to J2H4 mu Cl twice and B equal to J2H4 mu H twice, which is digalene. Yes, Tanya, do you have any doubt? Okay. So next question is the total number of bridging and terminal chlorine atom in Tl2 Cl9 3 minus is. Option A is 6 and 3. Option B is 3 and 6. Option C is 4 and 5. And option D is 5 and 4. The structure of Tl twice Cl9 times 3 minus is uh, Tl and 3 chlorine will be bridge, and 3 will be terminal on each. So on one thallium, one side there will be 3 chlorine terminated and 3 bridges. On the other side, again 3 chlorine will be terminated. So option B is the answer, where 3 bridging and 6 terminal chlorine atoms. Next question is diborane on treatment with NH3 gives. Option A is BH3.NH3, B is BHNH2 complex, C is BH2NH complex, and D is BH2NH3 twice BH4 complex. So we know that soft and bulky Lewis bases cleave diborane symmetrically, and compact and hard Lewis bases cleave diborane asymmetrically, because diborane acts as a Lewis acid. So diborane is B2H6. It has a structure like this: pH, two hydrogen bridge between two boron, and when we use NH3, which is a compact and hard Lewis base, it will be cleaving in asymmetric manner. So it will be cleaving like this. So this will be negative and this part will be positive. So the products will be boron, hydrogen, 4 hydrogen on 1 boron, and the boron with 2 hydrogen will coordinate to BH2NH3. So this will be BH4 minus and BH2NH3. So option D is the answer. And if we used NME thrice, so that will form a symmetric cleavage. That will be B diborane and NME thrice. So it will cleave symmetrically like this. So BH3 is formed. So 2 BH3 and they will coordinate to NME3. The structure will be B. The next question is the coordination number of aluminum in LBH4 thrice is option A is 3, option B is 4, option C is 5 and option D is 6. So here AlBH4 thrice, that is a boron hydride complex, and here is the structure. So here 2 hydrogen from one of the BH4 unit, it will form bond with aluminum, and 2 hydrogen will remain as terminal, and so here aluminum is octahedrally coordinated by 6 hydrogen from BH4 unit. So the answer is option D. Coordination number of aluminum is 6. The next question is the reaction of ethene with diborane followed by the addition of hydrogen peroxide results in the formation of an option A is ether, B is alcohol, C is organoborane, and option D is aldehyde. So let's write down the equation. We are asked ethane react with diborane. So ethane is C2H2 plus diborane B2H6, giving one product, and followed by hydrogen peroxide results in formation of next compound. We can call it as B. So B2H6 react with ethene to give will give a compound to CH3CH2 thrice B, and this on further hydrolysis will give ethanol and boric acid. So we use hydrogen peroxide, it will give ethanol CH3 CH2 OH and boric acid. So option B is the answer, and organoboranes are formed when ethene is reacted with diborane in ether solvent. So diborane we can write it as BH3 in ether solvent, it will be OR twice plus C2H2, it will form CH3 CH2 BH2 and will give OR back. So this is organoborane. Next question is BCl3 on treatment with copper gives option A is B4Cl4 and 4CuCl2. Option B is B4Cl4 and 4CuCl. Option C is B2Cl4 and 2CuCl. And option D is B2Cl4 and CuCl2. So, BCl3 react with metals to give B2Cl4. So, this is one of the method to prepare B2Cl4. So, BCl3 plus 2 copper will give B2Cl4 and 2CuCl. So, answer is option C. And when we react BCl3 with mercury, it will again form B2Cl4. So 2BCl3 plus mercury will give B2Cl4 and SgCl2. Next question is reaction of diborane with sodium borohydride yield. Option is A is NaB3H7 and B4H10. Option B is NaB3H8 and H2. Option C is NaB2H5 and H2. Option D is NaB3H8 and B4H10. So B2H6 react with sodium borohydride to give NaB3H8 and H2. At 363 Kelvin, and in diagram it will give NaB3H8 and H2. So this compound is used to synthesize higher boranes. So if you use 4NaB3H8 and react with 4HCl, it will give 3B4H10 and 3H2 plus 4NaCl. So if you want to synthesize B4H10, we can react NaB3H8 with HCl. And if you want to prepare B3H7Br compound, we can use 5B3H8 and 5SBr. It will be giving 5B3H7 Br minus and 5H2. And if you want to prepare B5H9, we can react with the HBr. At 373 Kelvin, it will give 3B5H9 and 4H2 5Br minus. And if you use heated at 435 Kelvin in diagram, it will form Na2B6H6. So 2 NaB3H8 heated at 435 Kelvin in diagram will give Na2B6H6 plus 5H2. The next question is B2H6 react with oxygen to give. Option A is boric acid and H2. Option B is B2O3 and H2O. C is B2O3 and H2. And D is boric acid and H2. So diborane react with oxygen to form boron trioxide and water. So B2H6 plus 3O2 will give B2O3 plus 3H2. So option B is the answer. Next question is the following statement are with respect to diborane, and option A is soft and bulky Lewis base cleave diborane symmetrically. Option B is soft and compact Lewis base cleave diborane unsymmetrically. C is hard and bulky Lewis base cleave diborane symmetrically. And option D is hard and compact Lewis base cleave diborane unsymmetrically. So we have to find the correct statements. So let's go through each one. Uh, First one is soft and bulky Lewis base cleave diborane symmetrically. So this statement is correct. Diborane act as Lewis acid, and in presence of bulky Lewis bases, symmetric cleavage take place. So if it's diborane is B2H6, so in presence of bulky and soft Lewis base like an Me3, it will cleave symmetrically like this. So BH3 and BH3 unit will be formed. So it will be BH and Me3, or we can write it as BH3 dot and Me3. So lone pair on nitrogen will be donated to boron. Next one is soft and compact Lewis base cleave diborane unsymmetrically. This statement is wrong because soft Lewis base will not cleave diborane unsymmetrically. They cleave symmetrically. And next one is hard and bulky Lewis base cleave diborane symmetrically. So this statement is wrong because hard Lewis base will cleave in unsymmetric manner. And next one is hard and compact Lewis base cleave diborane unsymmetrically. So this statement is right. So one of the example for hard and compact Lewis base is NH3. So if we use NH3, so NH3, the bond will be cleaving like this. So one boron will have 4 hydrogen and the other will be having only 2, and it will form BH4, and BH2 NH3 twice. So option C is the answer. The next question is the reaction of B4H10 with NME thrice gives. Option A is BH3 NME thrice and B3H7 NME thrice. B is BH2 NME thrice and B3H8 minus. Option C is B4H10 and NME thrice. Option D is B4H10 NME thrice and BH2 NME thrice plus B3H8 minus. So the structure for B4H10 is given here. So this red dots are for boron, and these blue ones are bridged hydrogen, and green are terminal hydrogens. So there are 6 terminal hydrogen, 4 bridging hydrogen in B4H10. So we are given a soft and bulky Lewis base. NME3 is soft and bulky Lewis base. So it will cleave symmetrically such that the boron will not have any charge. So the cleaving is done like this. So this B and the bridged one of the bridged hydrogen, that bond will be cleaved, and this boron and other bridged hydrogen, that bond will be cleaved. So it will be BH3 on one side and B3H7 on the other side. So here 1, 2, 3, 4, 5, 6 and 7. That's the 7 hydrogen on the one side with 3 boron. Here 1 boron and 2 terminal and one of the bridged hydrogen. So base on left side. So B4H10 presence of and Me thrice will give BH3 and and B3H7 and Me thrice, because this boron hydride part will be Lewis acid, so it will be able to accept electron from this nitrogen. So option A is the answer. Next question is the thermal stability order among B2X4 is. Option A is B2 NR twice 4 times and less than B2 OR 4 times less than B2 F4 less than B2 CL4. Option B is B2 CL4 less than B2 F4 less than B2 OR4 less than B2 NR twice 4 times. And option C is B2 CL4 less than B2 F4 less than B2 NR2 4 times less than B2 OR 4 times. And option D is B2F4 less than B2CL4 less than B2OR4 less than B2NR2 4 times. The thermal stability of B2H6 increases with the ability of X to form pi bond. So B2X4 is proportional to ability of X to form pi bond. So pi bond by back donation. So in the periodic table, the nitrogen and the nitrogen, oxygen, fluorine are closer to boron. Then chlorine is in the next period. So we are given nitrogen, oxygen, fluorine, and chlorine. So the order in the periodic table will be boron, nitrogen, oxygen, fluorine, and chlorine is in the halide below fluorine. So the energy of atomic orbitals will be similar to boron for nitrogen, then oxygen, then fluorine, then only chlorine will be coming. So the ability of these elements to form pi bond will be for nitrogen it is higher, then oxygen, then fluorine, then only chlorine. So the thermal stability will be B2 NR2 4 times, that will be the highest. Then B2OR 4 times, then B2F4, then B2Cl4. So you can find the same order here. B2Cl4 having the lowest, then B2F4, then B2OR 4 times, then highest for B2NR2 4 times. So option B is the answer. The next question is the solid state structure of aluminum fluoride is option is the dimer, option B is trimer, and option C is a polymer, and option D is a tetramer. So in ALF3, each aluminum center is octahedrally surrounded by 6 F atoms, each of which links to nearby aluminum center. So option C is the answer. So here each aluminum is bonded to 6 fluorine. So it is octahedrally coordinated, and those fluorine will be linearly bonding with a nearby aluminum. Next question is Al2O3 on treatment with HF gives. Option A is AlH3, option B is AlF6, F3, and option C is Al2F6, option D is Al2H6. This is one of the method of synthesis of AlF3. When Al2O3 is treated with 6HF, it will give 2Al-F3 and water. So option B is the answer. Next question is the oxidation number of thallium in TlI3 is option A is +3, B is +2, C is +1, and option D is 0. In TlI3, Tl exists in +1 oxidation state because the I3 is existing as I3 minus. So Tl is in +1 state and I will be in I3 minus. So option C is the answer. The next question is the reaction of BCl3 with ammonium chloride give product A, which upon reduction by NaBH4 give product B. The product B is option A is Cl3B3N3H9, B is BH3, C is Cl3B3N3H3, and option D is B3N3H6. So let's write down the equation. So first BCl3 reacting with NH4Cl giving product A, which on reaction with sodium borohydride giving product B. So BCl3 on reaction with ammonium chloride will give trichloroboracene. So 3 BCl3 plus 3 ammonium chloride will give Cl3 B3 N3H3 and 9HCl. And this is product A, and this on reduction will give borosine. Uh, 2p3 and 3h6. E2h6 and 6NaC. So this is product B. So we are asked to find what is product B. So option D, borosine is the answer. Next question is for B4H10. The skeletal electron pairs, that is SCP, and the structure type respectively are option A is 8 and closo, B is 8 and arachno, option C is 7 and arachno, option D is 7 and nido. We have to apply Wade's rule here. We are given B4H10. So total number of valence electrons, so 4 boron is present, so 4 into 3, that is from boron, and 10 hydrogen is present, 10 into 1, that is from hydrogen. So total will be 12 plus 10, 22, and number of BH units is 4. So SCP equal to 22 minus 4 into 2 by 2. That is 22 minus 8, which is 14 by 2, which is 7. In Bn Hn plus 6, we have n equal to 4 because we are given B4 H10 and SCP is 7. So that will be n plus 3. So here we can find for n plus 3, the structure will be arachno. So option C, SCP is 7 and arachno structure for B4H10. Next question is, following statements are about borosine, which is correct. Option A is each B and N atom is sp2 hybridized. B is borosine satisfies the 4n plus 2 pi Huckel's rule. And option C is like organic benzene, borosine does not give additional product with HCl. And option D is borosine contains dative p pi bond. Uh, let's go through each statement. First one is each B and N atom in borosine is sp2 hybridized. So this statement is correct because borosine will be like this and alternate double bond. So this structure is possible only when boron and hydrogen are sp2 hybridized, because for double bond formation we'll need unhybrid p orbitals so that they can overlap uh, um, in parallel fashion, so a pi bond is formed. So there will be uh, unhybrid p orbitals like this. So these will overlap like this, and pi bond is formed. And so this statement is correct. Next one is Morrison satisfies the 4n plus 2 pi Huckel's rule. So this statement is correct because in Huckel's rule, a compound is aromatic if it satisfies three conditions, or the molecules Huckel's rule. So one is the molecule will be having planar, and two is complete delocalization of electron, and three is uh, uh, yeah, you can go with two conditions here. So molecule should be having planar structure, so it's satisfied here, and two is complete delocalization of electron. So because of this uh, presence of alternate pi bond, it can delocalize the electrons. And third one is uh, for presence of 4n plus 2 pi electrons. Here, 6 electrons are present, which are donated by nitrogen present in unhybrid p orbital. So there are 3 nitrogens present. So from each nitrogen, there will be lone pairs. So they will give electron to nearby unhybrid p orbitals of boron, and form the pi bond and delocalizes in the ring. So there are 6 electrons. So that will be 4 into 1 plus 2 pi electrons, where n equal to 1. So it satisfies the Huckel's rule. And option C is like organic benzene, borosine does not give addition product with HCl. So this statement is wrong uh, because borosine reacts with HCl. B3 and 3H6 plus 3HCl will give uh, trichloroborosine, Cl3, B3 and 3H3 plus 3H2. So this statement is wrong. Option D is borosine contains dative p-pi bond. So this statement is again wrong because borosine do not contain dative p-pi bonds. So the electrons are delocalized. So option D is the answer. Uh, Next question is predict the structure of B5H11. So in B5H11 there are 5 borons. So there will be 5 into 3 electrons from boron. Then 11 hydrogen is present, 11 into 1. And then there are 5 BH units. So 5 into 2 should be minus. So that is 15 plus 11 minus 10, which is 16. And SCP will be 16 by 2, that is 8 skeletal electron pairs. SCP is n plus 1, so n will be 7. So here we are given B5, so 5 is n minus 2. So in closure it should be having n, and in cross middle it will be n minus 1. And in arachno will be n plus 2 and minus 2. In hypho n minus 3 and clado n minus 4. So we are given B5 which is 2 number less than 7. So it is it will be arachno. So in if there were n number of boron, that is 7, it should be closer type, then it will be pentagonal bipyramidal, has to be the structure. But we got arachno which is 2 borons are missing, so 2 vertices of pentagonal bipyramidal will be missing, so it will be like if all 7 were present, it will be having structure like this. So boron here, occupying all the vertices of pentagonal bipyramidal for clado, but we have arachno, so it will be having 2 vertices missing. So only 5 boron is present, so n equal to 5 arachno. So these 2 will be missing here. Next question is why B6H6 2 minus adopts octahedral structure. So in B6H6 2 minus 6 boron is present, so 6 into 3 valence electron from boron. Then we have 6 hydrogen, 6 into 1 electron from each hydrogen. Then negative charge is there, so it should be plus 2. Then 6 BH units are there, so minus 6 into 2. So total will be 18 plus 6 plus 2 minus 12. So that is 14. So SCP is 14 by 2, that is 7, which is n plus 1. And so the expected n is 6. So we have B6 at 6. So n is equal to 6. So we have a closure structure. So in closure structure having 6 vertices will be octahedron. So all the 6 vertices will be occupied by BH. So all the hydrogen will be in terminal position. 2 minus. So this will be the structure for closure B6H6 2 minus. So it is octahedral structure. Next question is why B12H12 2 minus adopts icosahedral structure. So again we'll apply Wade's rule. 12 boron is present, so 12 into 3, that is from boron, plus 12 hydrogen is present, 12 into 1, that is from hydrogen. 2 minus charges are present, so plus 2. Then 12 BH units are present. So 12 into 2, that is from BH. So that is 36 plus 12 plus 2 minus 24, and that will be 26, and SCP is 26 by 2, that is 13, that is n plus 1, and n will be 12. So we got n is 12, and here we are given B12 H12 2 minus, so number of boron is equal to 12. So it will be closure structure, and 12 having closure structure is icosahedron. So all 12 vertices will be occupied by a boron, and all the hydrogen will be terminated on the boron. Next question is what is the structure of B10 H10 2 minus? Here 10 boron is present, so 10 into 3 from 1 boron. 1 boron, 3 valence electrons, so total of 30 from boron. Then 10 hydrogen is present, 10 into 1 from hydrogen. Then 2 negative charges are present. Then 10 BH units are present. So that is 30 plus 10 plus 2 minus 20, that is 22, and SCP is 22 by 2, that is 11, and that is n plus 1, n equal to 10, and we are given B10 H10, so it is a closure structure. So n equal to 10 has for closure the structure is bicapped square antiprismatic. So that's all for today. If you have any doubt, you can ask.